Hi everyone, welcome to our webinar today. The topic for this webinar is Energy Storage for Puerto Rico, Modular Solutions for Disaster Recovery. This webinar is being presented by the Energy Storage Technology Advancement Partnership, also known as ESTAP. And ESTAP is supported by the U.S. Department of Energy and Sandia National Laboratories and is managed by the Clean Energy States Alliance. We have with us on the line today a number of excellent panelists who are going to talk with us about energy storage for Puerto Rico. And we also have on the line ESTAP Project Director Todd Olinsky-Paul. Todd will be talking a bit more about ESTAP, a bit more about our webinar today. And before I pass it over to Todd and to all of our excellent panelists, I'd like to go over a few quick housekeeping notes. All of our attendees for this webinar are in listen-only mode, so you can hopefully hear us, but we can't hear you. You have a couple of options to join the audio portion of the webinar. You can either call in using a telephone, or you can connect using your computer mic and speakers. If you'd like to minimize your webinar console so that you can view the presentation full screen, you can use this little orange-red arrow that's circled here, and you can also use that arrow to expand the webinar console. A very important note, we encourage everyone to please submit your questions throughout the webinar as you think of them by typing them into the question box on the webinar console and hitting send. We will be reading through your questions as they come in, and we will get to as many as time allows following our presentations. We're hoping to save at least 15 to 20 minutes for a Q&A with the audience. So don't wait until the very end to type in your questions. Type them in when you think of them, and we'll get to as many as we can. A final note, this webinar is being recorded. We will send you an email within about 48 hours with a copy of the webinar recording and with a PDF of the webinar slides. We'll also be posting those on our website at cisa.org/webinars. So with that, I will pass it over to our host for this webinar, Todd Olinsky-Paul. Todd?
Okay, thanks very much, Samantha, and welcome everybody to another in our ESTAP webinar series. Samantha, if you could just advance the slides for me, please. I'm going to briefly give a little background on our ESTAP program and then introduce our speakers for today. We have a good number of speakers and a lot of folks registered, so we are going to do our best to get to as many questions as we can. As Samantha said, please go ahead and type those in as you think of them, and we'll leave some time at the end for those questions. So the Energy Storage Technology Advancement Partnership, ESTAP, is a program that's supported by U.S. Department of Energy, Office of Electricity, and Sandia National Laboratories. It's managed by the Clean Energy States Alliance, or CISA. As you can see from the map, ESTAP has engaged in energy storage projects and other types of activities regarding storage, policy support, and technical assistance all over the map. We have a number of projects that are underway, some that are done, others that are in development. The focus here tends to be on larger scale energy storage projects, but this particular webinar is a little different in that we're really looking, at least to begin with, at smaller systems that are modular, can be delivered to areas such as today's topic in Puerto Rico, where the grid is down, where there are remote areas that need power, and where restoration of central grid power is going to take quite a while, and really can't wait. So we're looking at these sort of modular systems that often integrate energy storage with solar generation and can be put into locations where people can plug into them or use them to power buildings for critical facilities. So that's what we're talking about. If you could advance the slide, please. I want to just begin with a few notes from Dan Borneo from Sandia National Laboratories. He's the manager of the ESTAP project there. And he couldn't be with us today, or at least I don't think he will. He may be able to call in, but he's in Alaska and traveling, and so I'm not sure if he'll be joining us, but he did send a few notes. He wanted to remind us that these webinars are intended to provide food for thought and get the conversation started. We really, there's a lot of good people trying in many ways to restore power in Puerto Rico, and we don't necessarily think that we have all the answers, but we do want to facilitate a conversation and try to connect people. Whatever we do in the short term should be able to be included in the long-term solutions. So in other words, if we're putting short-term solutions on the ground, how do we later integrate those into longer-term solutions for the grid? Industry involvement is very important to provide ideas and implement solutions given the fast-track nature of repairs needed. And so, in other words, we, a small nonprofit located in Vermont, and Sandia National Laboratories and DOE are all working together, but industry is really important here. The folks that develop and produce batteries and solar panels and other important equipment that goes along with those and can transport and supply these things is extremely important. Everyone knows or has heard, I think, that there's a number of energy storage companies, Tesla, Sonnen, GS Battery, who's with us today, who are donating systems quite generously for this emergency situation in Puerto Rico, and that's really essential. And finally, we are open to suggestions as to how the webinar series can help and any other ideas about ways to help. Please do contact us if you think that there's something that we could do either through webinars or there's something else that the National Lab might be able to do or we might be able to do beyond this kind of information sharing. Please let us know. Next slide, please. So I'm going to introduce our panelists for today. I did change the order of presentation, so the panelists, this is the order we're going to follow. We'll start with Eric Gallant, I hope I pronounced that correctly, Director of Business Development at GS Battery. We're going to then hear from Cris Manickam-Shirley, the Energy Storage Market Manager at CivicSolar, and GS Battery and CivicSolar are working together, partnering on this effort. We will be hearing from Ian Munn, Operations Manager at Solar Foundation, which is trying to organize and provide sort of a clearinghouse for these solar and storage efforts in Puerto Rico. We'll hear briefly from Ofelia Mangen, again, I hope I pronounced that correctly, Project Manager and Volunteer Coordinator for Resilient Power Puerto Rico. We may have Resilient Power Puerto Rico back for a subsequent webinar. And that's it for today. So, and I'm the moderator, Todd Olinsky-Paul. I should have introduced myself, Project Director at the Clean Energy States Alliance. So let's move along here and begin the presentations. And again, feel free to type in your questions anytime. And thanks for being here. Okay, I'm going to pass this on to our first presenter.
All right. Thank you very much, Todd. Thank you, Samantha. Can everybody hear me okay?
Yes, we can.
Yep.
Okay, very good. As Todd mentioned, we're going to be talking about energy storage for Puerto Rico and really expand the conversation a little bit to some of the projects that we've already taken on in the Caribbean and talk about some of the modular solutions that we've developed for energy storage that can be used for disaster recovery as well. So just a little background. Sorry, I'm getting caught up in the slides here. Okay. So the value of energy storage. Here we go. All right, so the agenda will be, we'll go over the value of energy storage, we'll talk a little bit about some of our first steps, and then we'll get into some case studies where we talk about precisely how we've applied this technology in a variety of different cases with a variety of different outcomes. First of all, energy storage has a lot of value that actually preceded this recent hurricane season. A lot of the things that make energy storage valuable and a lot of the conditions on the ground in the Caribbean really lend themselves well to this technology. And so as a result, we had a lot of traction before the storms ever came. And this is because energy storage allows you to do a really large number of things and create a real value stack for the end user. One of the key ones is it allows you to integrate more renewable energy. And by having that energy storage, it takes a renewable asset like PV or wind that is intermittent, and obviously with the sun isn't shining, the solar panels aren't producing sun, but it allows you to bank that energy and use it at a later date. This really improves the performance and the value of both the PV and the energy storage. Now, all that leads us to increased energy resiliency and increased security. So a facility or a residence that's equipped with PV plus energy storage can operate in a mode where they're completely islanded from the grid. So what happens out in the grid doesn't affect the electrical stability of the site, provides a battery backup or UPS feature, and a reduction in the need for dependence on the grid for either financial reasons or for electrical stability reasons. And it also opens up a lot of opportunities for demand-side energy management. A lot of our customers are really reducing the amount of OpEx that they spend on energy procurement by adding PV plus energy storage and some of the other features of these systems. And it also opens up some energy arbitrage types of applications like peak demand reduction and time of use shifting, and a reduced impact of energy price fluctuations on operating expenses. So a lot of values there that are important considerations that are in addition to being resilient to tropical storms and hurricanes like we experienced recently in the Caribbean. So one of our first steps, and the way we really launched this this type of solution, is a project called Rescue. And I just want to talk about this briefly. This is a project that we worked on in collaboration and with the support of the U.S. Department of Energy and Sandia National Labs and a variety of other federally funded research and development laboratories. MIT had a hand in it, the Microgrid Testbed at Hanscom Air Force Base had a hand in it, and the Base Camp Integration Lab at Fort Devens in Massachusetts also had a hand in helping us steer the way this technology was assembled and deployed. The main idea was for forward operating bases. At the time we developed it, there were needs for forward operating bases in Iraq and Afghanistan, and even in northern Africa, where there were disease outbreaks, and they were deploying field hospitals in areas where there was little to no physical electrical infrastructure. So we had to be able to set something on the ground that would store energy and scavenge energy. And in addition, there was a strategic and tactical and financial problem around sourcing diesel fuel. Getting diesel fuel from the port out to these forward operating bases was a serious problem, because the convoys would take casualties. The fuel would sometimes end up in the hands of the enemy and became a strategic asset that they would use. In a similar way, we're seeing that in Puerto Rico, where there's assets that are available in the port, but the real challenge is getting those assets out to the areas where they're needed. And this is where the rescue system was able to show some real benefit to the military, and later in subsequent slides we'll explain how a similar product provides that benefit to commercial applications. So our design objectives with this product was, first of all, to reduce those diesel fuel rates, to allow the integration of renewable energy into this forward operating base microgrid and increase the overall reliability of the microgrid, reduce the maintenance cost, and some tactical advantages emerged from the project where we realized we were also able to reduce noise by eliminating some generator run hours and reduce the heat signature of these forward operating bases by relying on a insulated battery compartment versus, again, a noisy and hot diesel generator. The initial product was in a Tricon shipping container, and this is something that's a standard format for these forward operating bases. It's basically a third of a 20-foot shipping container, and we put 108 kilowatt hours of energy storage in there, along with a 250 kW bidirectional multi-port inverter, some rooftop solar, some energy scavenging capability, which meant that we were able to do distributed PV throughout the base on the rooftops of all of these different Tricons and bring that energy back to this common point for storage and distribution to the microgrid. It was also black start capable. We talked to some of the leaders of the military operations, and they said, we want to be able to put this device on the ground first. Immediately start it up without any connection to generator or grid and start delivering power to critical loads, and then at a later time be able to bring in generators to support the device, bring in solar to support the device, and bring in additional critical loads as those assets hit the ground. Again, something we developed for the military that was really useful in an area like Puerto Rico after the disaster. We can hit the ground, immediately start delivering the stored energy from the battery, and then as some of the other components of the microgrid come into play, or the grid is restored, we can continue to integrate those sources of energy into the rescue unit. Also, a lot of ancillary systems that go into just the safety and the operation of the system and the longevity of some of the components in the system. We do climate control and hydrogen detection and fire suppression and lighting and that sort of thing. So that was really our first step. We developed this really rugged, robust microgrid in a box for military operations. And as things wound down in Afghanistan and in Iraq and North Africa, we started to look for ways to deploy this same technology platform in commercial applications. And so we developed a number of other rescue type units. We did one that was 120 kW and 240 kilowatt hours in a 20-foot shipping container. And then for larger applications, we started to separate out our energy modules from our power modules, where we would have a 20-foot container that was full of nothing but batteries, 528 kilowatt hours, and then another that was nothing but power modules, where we would have 90 kW of power available. And this would also serve as the central brain and input and output for the rescue system. If you, say, scale up the energy modules where you're adding 5 or 10 of these energy modules, they're all communicating back to a single power module where power is distributed, and microgrid controls and power conversion and a whole host of power electronics are in that power module. And so you can see where solutions like these, they're good for areas that are trying to integrate additional energy storage, that are taking advantage of, say, peak demand reduction. A lot of areas will charge you more during a certain period of time, or if you exceed a peak demand threshold, they'll charge you more, so we can reduce that and, again, save a lot of operating expenses associated with energy management or energy procurement.
All right, Eric, and maybe I'll jump in at this point to segue. This is Cris at CivicSolar. Can you guys all hear me fine?
We can hear you, Cris.
All right. I think we're going to jump in a little deeper to 3 case studies in which we've deployed these systems, and we think are great examples for learning from our existing dispatches and trying to have some more rapid deployment in Puerto Rico with the idea of making essentially a rescue 2 unit that allows us to, with these case studies in mind, deploy fast microgrids to sites in Puerto Rico and other disaster-prone areas. So one thing that I think Eric, probably there's attendees out there that are like, why are we talking about lead acid still? Lithium's the future. But what Eric didn't mention in this presentation is we're working with a carbon lead acid AGM, absorbed glass mat, maintenance-free battery that gets rated 5,000 cycles at 70% depth of discharge for 10 years. And so at CivicSolar, we really see this as the bridge technology to bridge lead acid to future energy storage types. GS makes lithium batteries. They make a whole range of other chemistries. They're one of the largest battery manufacturers in the world. They've been doing this for 100 years. So they know what they're doing. And what we're seeing in the marketplace is right now, if for high cycle applications like microgrids, we're seeing that still, if we can utilize some of this nano carbon technology for AGM with lead acid, there's a lot of benefits besides just cycle life and besides the standard wins that you get from using a low-cost chemistry. So could you go on to the next slide? Let's see. Do I have the ability to go to the next slide? Oh, sorry. Great. So, I think, can we go back a couple slides? I apologize. So yeah, the St. Croix Cinema, a great example of a Caribbean project that actually recently experienced the damage from Hurricane Maria. When we got this project, the objective was to take a full-scale mega cinema and that was under construction and have it operate completely off-grid. And that was because of the high energy costs that they were seeing on the island. And so here's the project objectives. You guys can read through this, but essentially these were all our design considerations that we had to address in designing this. Some may call this a nanogrid of sorts, but it could do load following, it could do all of the things that we needed to do to both interconnect into a grid if we needed to, but really to function mainly off-grid and on its own. So you can go to the next slide. Do we have to click to get a photo? Or oh, there it is. Okay. So what we ended up with, somewhat because of budgetary constraints, we ended up with a 336 kilowatt-hour storage system, and I believe, sorry, I don't have the number in front of me, but I believe it was around 120 kW a PV system with diesel gensets tied in and backup diesel gensets. So we got all of the stats that I just talked about. Oh, one thing I forgot to mention is that these lead-acid batteries come with a 10-year warranty. So we are, not only backing up the cycle life with warranty. So we can really go into this with a lot of confidence. We used a medium voltage, so we strung these in series and created these are 2-volt cells. We've strung them in series to create a higher voltage DC bus that would match the solar bus that was basically had everything going into a multi-port ideal power inverter system that was handling both the PV and the batteries, and also had a tie-in for on the AC side for the generators, and all of that was being controlled by a field site controller that we had custom programmed to manage the operations at the site. And on the battery side, we had comprehensive stats being pulled off of every cell of the system. You can go to the next slide. In post Hurricane Maria, there was some significant PV damage. Some of the panels blew off the roof. They sustained, I believe, almost 200-mile-an-hour winds. So none of this was rated for that type of wind speed. But on the positive note, we were able to run the generators in combination with the battery bank to basically handle peak surges and lower the overall fuel consumption of the diesel gensets, causing there to be further fuel savings on the site, even without the PV. So the diesel gensets stayed. They didn't have to run as long, and they were able to provide power to the site through a post-storm. Of course, this is a cinema, so it's not doesn't seem like a great humanitarian need, but there definitely is something to be said for having a site online post-disaster, whether it's for entertainment or not. People want life to start to feel like normal quite soon. So let's go on to the next slide. We're going to also, I should say, we're going to expand that GS battery bank, and we're shipping out PV panels to get that PV system back online. Our next case study was in Haiti, actually a couple of years ago, just before Hurricane Matthew, it turns out. This location, it was a hospital in remote mountains of southern Haiti, and it's a fairly large facility for that region, and they had no access to utility power, so it's all diesel gensets, and they had a on-site hydro generator that was aging and causing really dirty in the sense of not a clean power source for the site. So a lot of the CPAP machines and were going offline and getting destroyed, and also just during surgery they were having loud brownouts and blackouts, and just lighting as a general basic need was not being met. So there was a long fundraising run. One of our customers, Smucker's Energy, was able to basically get a lot of donations to get basically a PV plus storage microgrid deployed to run in parallel with the generators and with the other on-site assets. You go to the next slide. So we did this system with it was an SMA AC coupled system. We had 84 kW of solar on the roof, and we had 192 kilowatt hours of these high cycle life GS batteries, which we ran at 48 volts and used the Sunny Island multi-cluster control unit as the sort of operations control for the site. The post Hurricane Matthew, one of the deadliest hurricanes in Haiti's history, they were sending the three other hospitals in regions pretty far away were sending their patients over to this small remote facility to get treatment because they had power post-storm. So big accomplishment there, we give thanks to Smucker Energy and Solar World and GS for all playing a vital role in bringing this microgrid online. Next slide, please. The last thing that I'll talk about, and this is all in relation to the idea that so somebody might be saying to themselves, this is not in Puerto Rico, but the idea is to learn from these case studies and reproduce them in a containerized solution like Eric talked about, so that we can deploy fast solutions that are needed for specifically maybe commercial grid-tied systems. That's where CivicSolar is seeing the majority of requests right now. Before, early on were small residential systems getting people back online, small life support systems. Now we're seeing the majority of requests are bringing on the commercial grid-tied solar. And so what we need is a microgrid in the box that we can wire up and deploy to a port and have basically it go to the site and bring that commercial solar system online with minimum configuration and minimum wiring and minimum labor on the ground, so that we can do fast deployment. So that is currently our goal with the Rescue 2 unit, and these 3 case studies, and we have a lot more that we go through. We just thought these highlight best the ideas and concepts that we're trying to deploy in Puerto Rico. So this is just another remote lodge, eco-village lodge in the rainforest of Ecuador, run completely on fossil fuel generators, just like a lot of the people in Puerto Rico now are running on fossil fuel generators to supply loads while their grid is down. And it was an eco lodge with obvious issues around running these diesel generators, and the costs were quite high. So you go to the next slide. Actually, the only access to this site was via these longboats, and we had to bring the battery banks on these boats as well. The objectives, I think we kind of went through this. They're self-evident, but we're lowering OpEx costs. We're providing better air and power quality to the site, and reducing the reliance on having to ship in diesel fuel. Next slide. And so we were able to actually handle that by deploying a relatively smaller system. We used the GS battery, their SLRs, their nanocarbon format. That comes in a 48 kilowatt hour chunk, 1,000 amp hours per cell, 2-volt cells. So when you wire that up in 48 volts, you get 48 kilowatt hours, 33 of which are usable on a daily discharge. We were able to use one of those banks with a 3-phase Schneider system to basically handle all their daily loads and have them consume a lot of solar and basically reduce their diesel run times to 0. This was an example of using using the system in a 48-volt configuration. Probably not needed for a containerized solution, but the idea here is to show you what we can scale down to and what we can scale up to. So that is it for that slide. And so these are you can definitely type in questions. We'll get those. These are contact informations if you'd like to reach out to us directly and talk to us more about the systems that you have heard about or are working on. And yeah, it was a pleasure to address you all today.
Okay, thanks very much. I think we do have a good number of questions, and maybe we'll take a couple of those before we move on. We usually save them all till the end, but can you just, before I start with these, can you just give us a little more basic information about what your activities have been in Puerto Rico, and just since the storms hit, and what you are looking to do in the near future there?
Yeah, so I mean, so far our activities have been immediate response. We've deployed over around 100 small-scale residential systems for customers with both grid-tied and no PV on site. And so a lot of the focus, a lot of the immediate deployment has been around these smaller residential systems. We've used a lot of GS batteries in 24-volt configuration. They have a standard AGM battery that gets 1,500 cycles at 50% discharge. That's a great value and available. One of the hardest things for deployment for Puerto Rico right now has just been product availability, and we've seen that we've seen a lot of systems get pushed back just because the products are not completely there for deployment. So that's been a lot of our, is drawing single-line drawings for customers that are doing, that are retrofitting both grid-tied and off-grid systems on the ground. And then the other half of the time is working on these larger projects, these existing commercial grid-tied systems, hotels mainly, that are trying to basically either avoid a service repair, transmission repair, A lot of those costs are getting pushed, in some cases, they're getting pushed back onto the customer. And so there's a lot of opportunity here for the customer to turn their commercial system, grid-tied system, into a microgrid and avoid the service upgrade and transmission repair costs. And so we're, that is what we're mainly working on right now, with and containerizing that to be deployed via the GS battery solution.
Okay. When you say residential systems, does that mean these are for individual residences, or does that mean they are simply smaller scale systems that are being used for commercial facilities as well?
When I say residential, I mean 120, 240. I mean homes, and certainly some businesses are both run out of homes and also use that service voltage. So yes, some businesses are onboarding systems, and we essentially it's a 120, 240 system. That in our book we call that a residential system.
Okay, thank you. So when you put these in, and I want to move on quickly. So this will be the last question for this before we move on, but we will get back to some of these questions in a bit. When you put these things in, how do they get controlled? I mean, if presumably there's no grid now, they're not getting a signal from some external source like a grid operator or a utility. How are they? Do they come with software? What's the controls side of it?
Yeah, so it varies across the commercial and residential spectrum, and in a lot of these cases, the systems that are getting deployed do have they can follow the load of the generator that's on site that's supporting the loads at the facility, right? So they can follow that and then start to form that, and then the generator can start following that load. So in this case, for the smaller systems, typically that software is on board, and you can build like the Hotel Lumiere. We built a 84 kilowatt SMA system using the SMA multi-cluster controller as the brains of the system. That has the ability to create a grid voltage that the PV system can respond to in an AC coupled mode, and when the PV inverters are put into off-grid mode. So via their web box and communication. So and same with the Schneider, that is able to start without most of these. Most of the existing older technologies have this ability. There's definitely issues with new deployments of like storage inverters and Tesla Powerwalls that have had issues turning on and creating a sine wave for the PV inverters to follow. But the other side of it is for like the St. Croix cinema. We used a system. It's called a field site controller from ELM, and we were able to use that to configure and be basically the master site controller to operate the generators, the PV, and the storage in concert to support the loads of the facility.
Okay, thanks. So let's move on to our next presenter now. And that would be Ian Munn, the operations manager from Solar Foundation. And so we're going to hear more about what the Solar Foundation is doing and trying to do in Puerto Rico, and what some of the needs are regarding combining those solar systems with battery storage.
Okay, great. Thanks, Todd. So everyone, my name is Ian Munn. I'm the operations manager at the Solar Foundation. First off, I want to thank Clean Energy Group for inviting us to be on this webinar. Hopefully this only helps progress all of the initiatives that are working in Puerto Rico as well as the USVIs. So I guess to start, I wanted to intro what the Solar Foundation actually is. We're a 501c3 based in Washington, D.C. Our main projects that we work on are the solar job census that is put out every year. Currently, that number is 260,000 solar jobs in the U.S. That's the number that's been floated around anywhere in the industry. So that's our main initiative. We also work on a couple of Department of Energy grants. We focus on both workforce development as well as a community designation program. So how we got started with Solar Saves Lives was in collaboration with the Solar Energy Industries Association, SEIA. They initially set up a donation page on their website. From that, they saw that they felt like we would be a good lead for that particular initiative, and therefore we took it over. So it's not just us that we're working with on this particular initiative. We have four other partners: Direct Relief, Operation Blessing, JPHRO, and the Clinton Foundation. So each of these partners have a particular specialty. Direct Relief is our medical partner. Operation Blessing serves as our logistics and shipping partner, as well as they've developed multiple partnerships on the island, most importantly with the mayor of San Juan. And then the Clinton Foundation serves as more of our network. They've graciously offered up some of their logistics help and their networking. And then JPHRO serves as our USVI rep. So from there, I want to kind of dive into the two particular projects that we are focused on. That first being the two priority medical clinics. Both are based in the San Juan region. Most importantly, the one in Rios Piedras, which is identified by Mayor Yulin herself. That particular site is in the south side of San Juan. It serves as a fairly important commercial marketplace, not only for the residents, but also tourists that are there, or any relief efforts that are there right now. She's identified that particular marketplace as a place for humanitarian relief efforts. These medical clinics, as well as, we're working on this is the medical clinics, I'm sorry. The medical clinics, the priority medical clinics, we have 62 medical clinics that have been identified by Direct Relief throughout the island. We've prioritized the first 10 being high critical areas, whether it's in a mountainous region or areas that have been without power 100% the entire time since Maria and Irma. We're working with New Energy. They're actively speccing out each of those particular sites. We've identified, obviously, the sites, but then also have realized within our 1 month effort that these sites that we're working on, obviously we're doing solar, but we wanted to include storage. We wanted to completely bring them off the grid, but as donations and commitments are being brought in, it's not looking like we're going to be able to fulfill the 100% load capacity for each of these sites. So we've kind of scaled back our particular initiative, and so for the clinics, we're only hitting their critical loads. The other initiative, like I already mentioned, was the marketplaces, Rio Piedras being the largest at 1.5 megawatts. President Clinton was there a couple of weeks ago. He visited with Mayor Yulin, our installer, Alejandro from New Energy, who's a consultant of ours based in Puerto Rico, and a few other individuals. Operation Blessings President Bill Foran was also there. And like I said, these marketplaces serve as a major commerce hub, as well as an area that Mayor Yulin has identified as a good place for humanitarian reliefs. So I wanted to dive into a little bit of the specs that we've been working on with New Energy. Alejandro has been a tremendous ally for us. He's gone to these sites personally, has spec'd out this particular marketplace. This is the marketplace that Mayor Yulin has identified. And I wanted to dive into a little bit of the project steps that we've been working on to not only alleviate some of the load issues that we may have, but also just to elaborate on the idea that CivicSolar kind of hinted that these particular systems need to withstand the next hurricane, because it's not an if, it's a when. So we're obviously going to try and reduce the load by improving LED lighting, but also just the efficiencies of any HVAC systems or other utilities in that physical structure. And then obviously working with coding and making sure that all of the PV that we would install is going to be up to any standards necessary. So as you can see on the sizing info, it's a pretty large system, and that's what our biggest issue that we're running into is this lack of adequate storage on a commercial scale being donated to us. And this particular image will show you the constraint that we're also dealing with, which is a lack of roofing space or just overall area around that particular marketplace for this existing system. So these are different issues that we're facing as we're moving forward with these particular projects. This is also just an aerial view to kind of explain the speccing that Alejandro is doing for us. So where we're at right now, we've gotten a sufficient amount of product donations for a couple of our smaller medical clinics. These clinics range in size from 15 kilowatts all the way up to 500 kilowatts. So these are a diverse set of clinics themselves. Where we're at is we're obviously currently and will continue to be taking in donations as well as commitments from anyone within the industry, outside of the industry. It doesn't matter whether it's in the United States or internationally. We are more than willing to take as many or any donations from any entity. That being said, and I've mentioned it earlier, our biggest ask is storage. So where we're at, and Civic again kind of hinted at this, we're at a position to where we want to do this right the first time. Therefore, we're not going to just willy-nilly install solar onto roofs before we have that storage aspect. We want to make sure that when we come in and install our systems that they can go off grid, or they can afford to hit that critical load to where the refrigeration systems within the clinics can be met, the needs of the clinics can be met the first time around, and the industry itself walks away patting itself on the back. So that's where we are with our initiative, and we welcome any questions, any suggestions, and I apologize for the snafu at the beginning.
Okay, thanks very much. Again, we have many questions, and we're going to hold most of them till the end, but it does seem as though, you know, there's a lot of good work being done here. I'm just curious, are you feeling like there's still a need for somebody to coordinate all these various efforts? I know that you're sort of trying to do that, but how much do you feel that all the various players are coordinated, and to what degree are they maybe just sort of going out alone? Do you have any sense of that?
From our standpoint, where we've noticed not necessarily adversity, but some of the groups that we've acknowledged are also in the sector, Resilient Power Puerto Rico being one of them, and we see all of their work as incredible. Also groups like Empowered by Light, Get Charged Up. We've talked to all of those groups, and we've identified that our initiatives are obviously important, and they all are fulfilling some aspect of relief efforts on the island, but we've yet to see anyone or deal with anyone that is really pinpointing these clinics as well as the markets. That's not saying that there are other groups that are planning on and are already doing smaller scale efforts on the island, but for the most part, we see our effort as independent and unique to the relief efforts in San Juan, and it's just one piece of the larger puzzle that is the relief effort for the USVIs in Puerto Rico.
Okay, thank you. And what will happen to all these systems down the line, say, a year, presumably the grid is repaired to some extent, power is back up. What then becomes of these? Can they continue to operate, or is that how they're configured?
Yeah, so our initial thought was that we would be grid tied. We would interchange them back onto the grid. But what we've uncovered is this issue, some of the issues with PREPA, and just in general the red tape that is that particular entity. So what we're imagining is that we would, these particular sites, whether it's it's mostly the clinics, they would serve as emergency backup systems, so that if for whatever reason the grid would go down, then they would still have that critical infrastructure to rely on for their necessary lighting as well as the refrigeration aspect. So those are the two main things that we've kind of identified as critical for the initiative itself.
Great. And one more question, and this is something that folks have written in about. Is the solar portion of these systems, what's its survivability in future storms? And I know we've seen images of solar fields in Puerto Rico that appeared to be quite damaged. And on the other hand, I have heard that there may be some very simple things that could be done in terms of retrofitting or future solar installations to make them much more resilient. What is your understanding of that?
So by having a consultant that's actually on the ground in Puerto Rico and went through the storm himself, he is pretty set on the fact that he's willing to reject any of the donations that we've been receiving from organizations that he doesn't feel like the products themselves will withstand any high wind, or for whatever reason, if the roofing's poor, then there's the issue at the marketplace itself that some of the roofing may not work for some of our racking. So he's taking that into consideration. Everything that we're going to be installing is going to be adequately rated. So from that aspect, Alejandro has already made that well known that he will make sure that our particular installs are adequate for the next storm.
Okay, so it is something that can be done, and it's just a matter of the racking and so forth being windproof.
Intelligent installs, I guess. So it's not just putting on solar to put on solar. It's taking the educated approach of this is what has happened previously. How do we mitigate it and make sure that it doesn't happen again?
Okay. Great. Thank you. So we're going to our final presenter for today, Ofelia Mangen of Resilient Power Puerto Rico. Resilient Power Puerto Rico was just mentioned by Ian Munn as one of the organizations that's doing great work, and we've discussed having them on a future webinar. So today's presentation is going to be relatively brief, but just to sort of give you a sense of what they're up to, and as I said, we may have them back in the future. So go ahead, please.
Hello, everyone. Thank you for inviting us to join today. It's wonderful to get to hear more and learn about the work that everyone else is doing, and also to see that we all seem to be facing some similar challenges. So Resilient Power Puerto Rico was built on the model of our success with the Power Rockaway Resilience Project after Superstorm Sandy. And we started with some nimble, really targeted efforts to deliver solar generators to the most underserved areas in Puerto Rico. And by getting below wholesale and donated sort of overstock components, phase one was focused on building these triage power systems, and we were able to accomplish that for less than $2 a watt. These scratch-built systems really we're at about a tenth of the cost of the turnkey solar generators, and then we had the added benefit of being able to teach local community members, about the solar systems as we build on site. The Phase 1 relief measure has supported communities in this immediate aftermath of the storms to power the cleanup and relief efforts and to get them back in the communication loop as well. We're currently transitioning to our Phase 2 and our planned evolution into more long-term disaster preparedness and clean energy solutions. Phase 3, which we expect will take us into 2021, it will be focused on town microgrids and sponsored installation by local companies. So to date, we have raised about over $1 million in combined monetary and solar material donations. A lot of this has come through cultural events such as concert that happened in Rockaway the other weekend, and other fundraiser events by PTAs and public schools in New York, gallery shows, parties, yoga retreats, birthdays. It's really been encouraging and wonderful to see all the creative ways that people have come together to support our efforts. And I gotta say, the New York solar community and the national US solar community have also come through in a huge way by in-kind donations of equipment, staff being able to take time and come and work with us to design these scratch-built systems and install them in Puerto Rico as well. So we have a number of institutional partners. We've had volunteers come through for more sustained efforts, but also just showing up to static solar panels in Brooklyn to ship them over there. We've had some really dedicated volunteers who've taken leads on the effort, such as Wiley, and who started a solar salon with volunteer University of Puerto Rico students who are learning about this while helping to install the solar generators. And starting in Phase 2 and moving forward, we're starting to work with them to talk about sort of green job placement opportunities and what it means to create a renewable economy around this in Puerto Rico. So we were able, with a donation, to purchase the Sun Commander, which is a turnkey solar generator, and that was installed at the hospital in Isabela. The Hispanic Federation, in partnership with Lin-Manuel Miranda, have transported our equipment there, and then also, you could see here in the background, a private jet full of equipment for us to install an acre of solar. We've been able to work with Tesla, and they've donated a couple of power walls, one of which was installed in the Buena Vista Community Center. And we've worked with other sites, such as this hydroponic farm in Utuado, who are growing lettuce and getting it to, they're supplying some restaurants and then also some other folks who are doing relief work in distributing food as well. So just a quick little overview of the work that we've been doing. I think an immediate sort of needs are across the board, like with everybody else. Equipment, donations of equipment. Anyone who is interested in coming to Puerto Rico and working with us on a future deployment to help support installations, and anything else that anybody can be creative in thinking to contribute to our efforts is much appreciated.
Okay, thanks very much. Thanks to everybody for presenting, and we have a bunch of questions. I'm going to start with a couple of questions that I have, and then we'll move to the ones that have been sent in. We've heard that there has been in this effort difficulty getting batteries. I know there are numerous battery companies that are stepping up, including GS Battery, and we did a previous webinar with Sonnen Battery. They've sent some units. Tesla sent some units. But from the folks at the Solar Foundation in particular, and the Resilient Power Puerto Rico, is it the case that it's more difficult to get the batteries than the solar panels? And if so, what's the scope of the need really? I mean, obviously, you could ask for everything and anything, but realistically, what's the size of the hole for batteries in this case?
So I can speak to that a little bit. We initially had, that was one of a big challenge for us, particularly before the first deployment. And the engineers and technicians who were working with us then were actually able to put together a 2 kilowatt system that could function without batteries, which for a relief effort, something is better than nothing, right? But that was a challenge. And when we were able to find batteries, getting them transported was a big problem. I think that's become less so, but there is an issue right now in terms of the availability of them, and for an operation such as ours, where we're trying to direct funding as much as we can to get things on the ground. It's an additional type of challenge when having to consider the transportation. So we found some solutions. Not all of them are, imperfect at best, but we certainly welcome anybody that has any creative ideas about how we can continue to keep that supply chain running to support our efforts moving forward.
Just to echo what Ofelia is saying, most of our monetary contributions, and I guess just to put this in a more blunt way, is the majority of our monetary contributions will be going toward our purchase of storage systems, strictly because there is a lack of those particular systems to the scale that we need in the marketplace that are being willed out for donation. So similar to what Ofelia has been saying is what we've also encountered. A lot of the manufacturers that we've been working with have given us the intel that most of the larger scale batteries or storage units are being manufactured at a slower rate than first predicted. So it's they're almost being manufactured as if they've already been purchased for. So there's not much of a surplus for donated batteries. So that's the issue that we're running into. But like I said, we're now turning our efforts to any of our monetary contributions going directly towards that storage aspect.
Okay, great. So if there's anybody listening who is representing a battery company, and you have some batteries available, you know who to contact to donate them. Here's a question from somebody who's attending the webinar. What is the ballpark installed cost of a residential level system? And I'll try to elaborate on that a little bit. What are we looking at in terms of installed costs for some of the different sized solar plus storage systems that you folks are distributing in Puerto Rico? And let's identify the size of it and the approximate cost.
So Resilient Power Puerto Rico is looking at 30 kilowatt systems in the $40,000 to $50,000 range, which we're working mostly with community centers, and other types of places like that. So.
Okay. Any other examples? Cost?
Yeah. So, and I can talk to that a little bit. We've been working with a couple of volunteer consultants in the States, and just based on going through every single facet of the install, whether it's the materials, labor, logistics, a 150 kilowatt system we've been spec'd out at around $500,000 with storage. Just to give you a larger scale system.
Okay, great. So it kind of begs the question. I mean, is this, is this an efficient solution? Is it the only solution in certain circumstances? Is it a choice that's being made for other, external reasons? For example, is it hard to get diesel fuel? Is it hard to get diesel generators? Is it difficult to transport them to certain areas of the islands? Can we talk a little bit about that, because we have a lot of questions about cost, relative to other types of technologies. Obviously, there are benefits of solar and storage. It's clean. It's doesn't rely on fuel deliveries. It scales up and down quite well. But maybe you guys can talk a little bit to why you're, in the first place, you are interested in providing this specific technology solution.
Yeah, I mean, this is Cris at CivicSolar. The cost structures vary drastically among customers and applications. So there's no there's no clear answer there. There's often going to be costs that are unique to a site that or priorities that are unique to a site that elevate that as as it being a solar plus storage solution, or qualify it to being a solar plus storage solution. So I think we talked briefly about this in some of the case studies, but basically it can be service upgrades. So the site might need more energy to be delivered to the site than is currently available, and that might cost $50,000 to $150,000 to upgrade the service line to the site. It can vary widely, and that cost can be mitigated by deploying a microgrid of sorts, where in that case maybe you're just using some of the loads are being supported by the existing grid, and then the additional loads that are being added to the site are being supported by this this resilient microgrid. I mean, just to use those words, we also are talking about facilities or people that have interest in maintaining power, while the grid is down, while there's not fuel supply coming to the site. And one thing that we can do at our offices is we can use a software called Homer Pro and model the generation cost, and including the if there are on-site generators, and even to the point of fuel sensitivity, so you can see how much storage would you add if prices of fuel go up to this level? How much storage do you need to add if prices go down to this level? And so it's a constant multivariable optimization problem where you're trying to find the best value for the customer. Besides just cost and levelized cost of energy for the site, there's that resiliency factor, which is something that doesn't get, it's hard to put a number on it, but you can look at, like a hospital does, look at the cost of replacing medicine as it goes bad because the temperature in the refrigerators dropped 5 Celsius below what they should have because of an outage. So you can start to pinpoint costs associated with that, and as you stack up all those costs, you can get closer to what a real-life model for energy storage would be if you were able to, say, have a facility that was not going to lose power, or specifically for certain critical loads not lose power, and what that value might be.
Okay, thank you. Somebody wants to know who ends up owning these systems once they're installed. Is it PREPA? Is it the final? Is it the customer? Are some of them ownership, or some of the ownership retained by the provider, or what happens to them?
One conversation that Resilient Power Puerto Rico is having right now is with communities, and what that means for everyone to have, especially the initial expense for something like this in the longer term, for it to be a shared cost that everybody can benefit from. So I don't know if that specifically answers the question. The installations that we've been doing have involved local partners. So the institution, say we installed a system at an orphanage last week, so that is now theirs to make use of, for the work that they're doing. So because ours has been sort of a community relief effort and has specifically, we've not done any installations at private residences, but instead working with community organizations that have been supporting relief efforts and that have an impact, in the community. They are the beneficiaries of the work that we've been doing.
And so they will own the systems?
It's going to vary site by site. So depending on what we did. So the orphanage was one example where we did do the installation, and they now own it. So the Sun Commander at Isabella Hospital is, again, sort of it's supporting an immediate need, but it's not enough to power their complete operations. So, as they are working to get something in place, that conversation is ongoing. So it's going to, for us, it's going to differ site by site. And as we move into phase 2 and 3 with the renewable economy, as I said, whereas a single homeowner might not actually be able to afford to install their own solar power system, what happens to the conversation when you're talking about a community, neighbors and everyone who are together? Does that then make it feasible for them, and what does that look like?
Okay, so it sounds as though it differs from instance to instance. There's somebody who has written in asking a question about PREPA gridlock on the wheeling tariffs and what's being done in that regard, and says they've been reluctant to open the market on private generation and accumulation by private entities. Can somebody explain what that's about, the wheeling tariffs? Okay, nobody wants to take that one on. Is there an issue with getting these systems in that has to do with PREPA? Okay, anybody? All right. So I'm not sure what that person was asking about, but we'll move on. Somebody wants to know what you do when you have a situation with tin roofs, poor roof conditions. We talked about a little bit earlier, but let's expand on that a little bit. Are you folks doing any sort of either retrofits, involving building upgrades, or are you looking for opportunities for ground mount systems outside of facilities where the roofs can't support the solar? And similarly for the storage component, what do you do when there's no place to put the batteries? Are you looking at interior, exterior, shipping containers with some kind of HVAC system to keep things at proper temperatures, or how do you handle that?
This is Eric with GS Battery. I can speak briefly to the battery side. We have a number of different battery chemistries. Some of them are more suited for high temperature applications and can be put in unconditioned areas. But for the most part, especially on the larger installations, we like to use some sort of a shipping container that's been modified for the purpose and has climate control and maybe some of the other ancillary systems like fire suppression, fire detection. And that really allows us to, exist outside of an existing building and maybe, set aside some building code or fire code concerns, and also deploy rapidly. In other cases, we'll do an open 2-post telco rack in someone's garage or the basement of a commercial or industrial facility.
Okay. What about the solar? What about the roof issue there?
Well, I can speak. I mean, we're not doing structural retrofits, but there are a lot of ways to deploy solar, outside of the maybe what's considered traditional. But there's S5 clamps that you can use to pinch the seams. There's S5 also makes a product that can go through the metal roof and into the structural membrane, or sorry, member of the truss, and tie into that, so you don't have to rely on the tin material itself. There's also, you can do a low-cost ground mount system. We even have a ballasted ground mount system that you can put ground screws, have it sit on the ground. It's about 24 inches off the ground, and you lay it out just like a roof mount ballasted system. So that's a good way if you have some small land space and you don't want to do any concrete footings or anything like that. You can either ground screw, or this is with hand drills. So I'm not talking about something that's really complicated. You can also use concrete blocks and drop those on to the racking structure to ballast it down, and those are rated for high wind speeds. So there's a variety of options for racking modules if the structural members are not able to support the excess weight, but it's a project by project estimate on what approach would be necessary to achieve the goals.
And I guess just to add to that, the majority of our sites, the structures themselves have been sufficient for the majority of the racking, but there are instances where Alejandro and our other installers have opted for ground mount systems strictly because of the lack of infrastructure on some of the sites.
Yeah, and this is Devavrat with Resilient Power Puerto Rico. In addition to the previous points that the two gentlemen made, the systems that we design and install in Puerto Rico are meant for rooftop systems as well, but there's no necessary restriction on them to be fastened onto the roof. They can also be ground mounted, given that the uncertainty of conditions in the recent disaster area. We have kept it quite flexible for installation.
Okay, thank you. There has been, a lot of talk about, what do we have, or if not, why don't we have these sort of pre-packaged solar and battery solutions with maybe a small generator attached with built-in inverters and plug points and so forth that can be dropped. I know that in speaking to Eric, earlier we talked about the rescue modular unit that was developed for the military. It probably is, if it's at military spec, it's probably overbuilt a bit for certain applications, but how, what would it take to adapt that sort of product to a sort of cheap, easy to transport modular solar and storage, portable generator that you could, for example, provide the way that diesels are often provided as a sort of a trailer, trailered in, trucked in, distributed solution, short-term, very quick solution with rather than, being dependent on fuel deliveries, you would simply have to pop up the solar and set it out in the sun for a while and then start using it. Is that something we're approaching, or is there anyone working on this that you know of?
Todd, again, this is Eric. Yeah, we're absolutely working on that. Really the reason that I presented the information about the rescue unit is because we're pretty ferociously working on commercial applications of that same technology footprint. Some of the things that you mentioned in really the list of wants there may not all happen at once. Like, for example, you mentioned inexpensive and easy to transport. Well, if you're going for an inexpensive energy storage solution, probably means you're looking at a lead acid or a lead carbon battery. and just by the nature of lead, it's not going to be easy to transport. It's going to be heavy and take up a lot of volume. They're rather massive batteries. But as far as the functionality of the system goes, we absolutely have energy storage systems that are containerized. We have the power conversion that's containerized, and we have the ability to mount solar on the roof of those containers. And we have the ability to bring in either generator or utility power to that device. So you have your choice of grid or generator. And then we have distribution. So you can rapidly connect your critical loads using either some sort of a cam lock or pin and sleeve connector to connect to your most critical loads. So these systems are definitely designed. It's really the same thing that we showed you in the case studies for St. Croix and for Haiti to some extent, and really just putting that entire system into a mobile 20-foot shipping container. The problem is, like most battery manufacturers, and as one of the callers was mentioning earlier, we're constrained on inventory. These designs exist, the components for these designs exist, but batteries are a rare commodity, and we can't have one of these devices or a fleet of these devices sitting in storage somewhere waiting for the next hurricane so we can roll them out at this point. So it may be that, you know, the answer is an organization like maybe a FEMA purchases a few of these for rapid deployment, but as a manufacturer, we can't tie up that much capital in having them on hand.
Sure,
Yeah,
but that's not usually the way that these things are done, right? I mean, the manufacturer would, as you say, sell them to the emergency management agency, the state, you know, emergency coordinating centers. You know, I mean, there are these things are out there, at least in other technological areas, such as you know, diesel gensets, which are fairly ubiquitous. I mean, they're out there. Presumably, you know, if there were a competitive product, it would be bought by those in the emergency management, you know, area, and they would do the deploying and the upkeep and so forth, right? I mean, I wouldn't expect the battery manufacturer to do that necessarily. But I think somebody else was about to jump in.
Yes, I would just wanted to add to the points that Eric mentioned and to the question that if we are going towards compact solar chargeable battery packs, which can be used for domestic applications, well, as of now, there are only a few manufacturers which are making these kind of products which can directly be charged by solar panels. But the main challenge, I think, when we were designing or looking for quick solutions for deployment in Puerto Rico were that often what happens is these systems, if we try to mix and match these components, do not often gel well with each other or are incompatible. And off-the-shelf products which do offer similar solutions, which are small battery boxes with AC outlets on them, are often not enough for, do not hold enough charge or are not enough for use over an extended period of time. While they can be appropriate for use, for recreational use such as camping, but definitely I think disaster relief power generation would require a different kind of solution, which I have not seen so far. But yes, we are definitely going towards that direction, where we can see a few products, commercial products, in this domain in the future.
Yeah, yes, I've seen those the small ones that, as you say, are used for camping and so forth. It seems odd to me that there are those recreational, you know, products, but somehow there's a hole, there's a gap here, and I'm just trying to figure out, you know, why that is for something that would be useful for this kind of emergency relief. And related to that discussion about storing these things, and we have some questions about system life expectancy. What is the life expectancy of the systems that you folks have been distributing, and you know, is that an issue in terms of you know, sort of down the line, being able to integrate these things into the grid or into a, you know, sort of a longer term solution?
So in the first phase of deployment, the systems that we designed were basically to help resurrect the completely you know, destroyed power system down there. So our first priority was to get critical operations working down there, like hospitals or health clinics or restaurants which can make food, and also provide local communities with charging stations to charge their local devices. And yes, we also design them in a way that they can be plugged onto the grid afterwards, or a couple of them can be combined and form a microgrid or a bigger system later on. While some of the systems, like the smaller systems that we designed, were coupled with battery storage, they had been designed in a way to just make sure that the rescue teams which have been present down there have emergency and quick power to their disposal. While those systems can, the solar panels used in these systems can be plugged onto the grid later on, but I'm not necessarily, I cannot vouch to the fact that the storage systems can be used over a longer period of time than a year or two.
Regarding storage systems, the battery that we most commonly deploy to the Caribbean for microgrids and nanogrids and for use with PV carries a 10-year warranty, and it's designed for 5,000 cycles at 70% depth of discharge. We're currently testing this battery to a standard called IEC 61427, which is a simulation of conditions in a typical PV environment. It takes into account the variability of the seasons and the partial state of charge and a variety of other factors. And in that test, each cycle is equivalent to 1 year of service. And this SLR battery, this lead carbon battery that we're talking about, is currently in year 13 of that IEC test, and there's been no loss of capacity on the battery. So what that means is that the failure criteria for that test is when the battery doesn't recharge to 80% of its initial rated capacity. Right now, our batteries are recharging to more than 100% of their initial rated capacity. So we don't actually know when the battery will die, but it's well past 10 years, and it's warranted so.
All right, thank you. That's very impressive. So we're about at the end of our time. I wanted to thank all of our presenters, Eric Gallant from GS Battery, Cris, Manickam-Shirley of CivicSolar, Ian Munn from the Solar Foundation, Ofelia Mangen of Resilient Power Puerto Rico, and Devavrat Kadam, also the solar engineer and designer from Resilient Power Puerto Rico. Thanks everyone, and all of our attendees for joining us. And I also want to thank Sandia National Laboratories and DOE Office of Electricity for supporting our program here in energy storage and funding these webinars. And thanks everyone. We will be back in the new year with more. Okay, bye-bye.